All right, so now that we have gone through and done different types of distribution graphs and computations with like the 5-number summary, median, mode, interquartile range, we are going to do a little bit more interpretation of this and start talking about this word variability. So you'll see a lot of overlap with some of the things that we have been working on here, but also now doing a little bit more interpreting the meaning of some of these things. All right, so the first problem has us go ahead and take a look at some data. The heart rates of 8 high school students are listed in beats per minute. And the first question is, what is the interquartile range? So the first thing we have to do then is think about, all right, well, that means I'm going to have to do the 5-number summary and take a look at that Q3 and Q1, the upper quartile and the lower quartile. So let's go ahead and put these numbers in order from least to greatest first, because that's what's needed in order to do the 5-number summary. So let's see. We'll have 72, and maybe cross them off as you go here. We got a 75, and we have a couple of 76s, and then 77, 78, 79, and 81. All right, so now they're in order from least to greatest, and let's now go ahead and compute where the median is going to be. So we know the min, we know the max, and so let's do the median. So there's 8 numbers here, which means that the median is going to fall between the 4th and the 5th number. So that means that our median is going to be halfway between 76 and 77, or the average, 76 plus 77 divided by 2 will be 76.5. I guess technically we wouldn't necessarily need that if we're just looking at the interquartile range, but I always like to start with that, and we definitely need to figure out where the median is. So then we're going to compute the lower quartile, the Q1 value. So remember, interquartile range is Q3 minus Q1. It's that middle range of those between those quartiles. So we're going to compute Q1 first. There's 4 numbers to the left of the median. So then that means that the median of the first half will be between the second and third number there, which is between the 75 and the 76. So 75 plus 76 divided by 2 will be 75.5. So 75.5 is going to be our Q1 value. So Q1 is 75.5. That's our 25th percentile, or our lower quartile. And then we have the same thing on the top half of the numbers. There's 4 numbers there. So Q3 will be between the second and third, the median of that top half, in other words. So that would be 78 plus 79 divided by 2, which is 78.5. So 78.5 will be our upper quartile. 78.5 is Q3. So the interquartile range will be Q3 minus Q1, so 78.5 minus 75.5, which is an interquartile range of 3. And in this context, that means it's beats per minute. 3 beats per minute is going to be the interquartile range. So the IQR right here is 3 beats per minute. And the IQR, we're going to start talking about this, is a measure of variability. So a measure of variability is how spread out is the data. And rather than thinking of the entire range as a good measure of variability, we think of the IQR as a good measure of variability because it's the middle half of the data. How spread out is I'm going to actually put the middle 50% of the data. So I think that's probably a better way of thinking about it. So how spread out is the middle 50%. And that middle 50% is important because we don't really have to think about the highs and the lows, but that middle of the group, how spread out is the middle of the group. So in this case, the middle 50% of the students have heart rates that are within 3 beats per minute of each other. So it doesn't seem like a huge spread, doesn't seem like a huge amount of variability here. So it starts to give us that particular information. So how many values in the data set are less than Q1? All right, so less than Q1, so remember Q1 is our 75.5. So there's 2 values in the data set that are less than Q1. Between Q1 and the median, so that would be 2 more data values. Between the median and Q3, 2 more data values. And between Q3 and the maximum are greater than Q3, and that would be 2 more data values. So you can see that we have essentially spread out the data into 4 equal parts. So 2 data values, each one of those is 25% of the data, 1/4. Each one of those is like 25%, another 25%, another 25%, and another 25% adds up to 100%. So when we are separating these out, we're separating out into equal parts, 4 equal parts. And each part is 25%. So there'll be the same numbers, the same number of numbers in each part. All right, number 3. A pod of dolphins contains 800 dolphins of various ages and lengths. The median length of dolphins in the pod is 5.8 feet. What information does this tell you about the length of the dolphins in the pod? All right, so let's just highlight a couple things here. So the median length is 5.8. There were 800 dolphins. All right, so if we listed out all the dolphins in their length, there'd be 800 numbers, right? And halfway through that would be the median. So the median here will be the average. So let's say the average of the 400th and 401st dolphin, right? So there's an even amount of numbers there. There's 800 numbers. And so if we put them in order from least to greatest, we'd have to average those middle 2 numbers. So 5.8 feet is the exact middle number. For length. And like I said, it's the average of the middle 2 numbers, since there's an even amount of numbers. So what does that mean? Well, if we separate this out, that means that there are 400 dolphins, which is 400 dolphins have a length of less than 5.8 feet. Since it's the median, that means it's that 50th percentile, which means half. It's the exact halfway point. So 400 dolphins have a length of less than 5.8 feet. And then also 400 dolphins have a length greater than 5.8 feet. We're not sure exactly what the maximum or the minimum is here, but if we know that the median is 5.8 feet, that means that half of the dolphins, in this case, half would be 400 of them would be less than 5.8 feet, and 400, the other half, would be greater than 5.8 feet. All right, so that's the interpretation of the median there. And then let's take a look at our last problem here. The same vocabulary test with 50 questions is given to 600 students from 5th to 10th grades, and the number of correct responses is collected for each student in this group. The interquartile range is 40 correct responses. What information does this tell you about the number of correct responses for students taking the test? Okay, so that's a lot of stuff there. So there were 50 questions total, and there are 600 students. All right, and the interquartile range is 40 correct responses. All right, so let's do a little interpretation. So let's start with the interquartile range here. So the interquartile range, remember, IQR is going to be the Q3 minus Q1, upper quartile minus the lower quartile, and we know that's 40 because we're told that that's 40 up here. So 40 is the interquartile range. That means that that middle 50%, remember what we talked about here above, that if we divide the group of numbers with the median, Q3 and Q1, we really divide it into 4 equal chunks. And so the interquartile range will be that middle 50%. So the middle 50% of scores has a range of 40 correct responses. Correct responses. All right, now think back of also what that could really tell us here. There's 50 questions on the tests. So we're saying that the middle 50% of the students has a range of 40 correct responses. So that's quite a big number of students. If we divide 600 into 4 equal parts, so that would mean that there's 150 students, another 150 students, another 150 students, and another 150 students. So that adds up to 600. We're talking about the middle 300 students. So the middle 300 students have that range of 40 correct responses. So that's a lot of variability. I mean, you're thinking about variability there and thinking about what that might even look like on a box plot. Box plot might look something like this. So possible box plot. Think about we have scores here that go up to 50. So scores. And you're talking about that middle range is going to be from one side to another side. That's going to be a range of 40. So let's say that someone had a score of 0, and let's say our quartile 1 was, say, 5, and let's say our median was 30, let's say our quartile 3 was 45, and let's say our maximum was 50. All right, so if you look at this box plot, here's the box plot. Notice that I'm going from 5 up to 45, and this is a possible box plot. It might look a little bit different than this because we don't have all the information. But this interquartile range right here is from 45 down to 5, so that's a distance of 40. So this distance right here on the box is a range of 40. That's the interquartile range. You can see that that middle 50% of the data is very spread out. You know, there's just a little bit down into the minimum here and a little bit up to the maximum, but that middle 50% is very spread out. So there's a lot of variability with this particular test then and the scores. So if I were a teacher looking at this, I'd be like, okay, the scores are kind of all over the place here because 75% of the scores are below 45 and then 25% are below 5. So that is the interpretation of the interquartile range of 40 responses.